Hey guys, welcome to my channel. This is Satyajit Pattnaik, and today's topic is going to be about one of the end-to-end machine learning and deep learning projects. If you remember, I had done a small poll on LinkedIn a couple of days back about asking about what should be my next video, and most of the people told that it has to be an end-to-end machine learning project. And here we are, we have come across this awesome project which is being created by four of the folks in Hong Kong. They have done this project in just a month, which was part of their capstone project in one of the boot camps in Hong Kong. Of course, the boot camp is by Accelerate, the company where I work for, but this is not a paid promotion. Anyways, so we'll talk about these folks. One of them is Kelvin. The second one is Brian, Steffi, and Sofia. So definitely I'll leave all of these profiles in the description below so that in case you have any doubts in this particular project, you can reach out to them. And of course, you can reach out to me as well in case you are stuck somewhere. Okay, so these are the four guys who have done this project, a beautiful project comprising of a lot of things like data scraping, and then, NLP, recommendation engine, deep learning concepts. They have also used Inception V3, if I'm not wrong. So a lot more things has been done in this project. It is a complete package, guys, to be very honest. I have them waiting in the waiting room. We shall connect with them very soon. Everything will be provided to you, that is in the description below. The code will also be given to you, but there is a catch. The catch is I have to get 10,000 views in this video and just flood with all your comments, the background you're coming from, whether you like the video or not, anything, but you should leave a comment. Of course, once I have 10,000 views, which is in couple of days, I know that you can make it happen. You can definitely share it across your friends and make it happen. So once we have 10,000 views, we will be sharing the code, guys. To be very honest, the code is, it's an end-to-end project, right? So uh, it has to be a give and take kind of concept. So that's the reason I'm not making it public very immediately. But anyways, so let's get started. We will talk about the project details and all those things in a couple of minutes. Just giving you a brief idea that this project is HK WhiskyNav. It's an integrated application using machine learning to provide whiskey identification, selling info, consolidation, flavor analysis, and recommendation services in one go. Now, just a brief overview of the project. Of course, we have all of them waiting. They will be talking more about the project because they are the ones who have created this project, right? But this project is something like, uh, how many of you have, you go for buying whiskey and you end up in, inquiring in multiple shops, and you identify that some shop is selling it for $1,000, some shop is selling it for $1,200, some selling for $500. So the prices differ from shops to shop. It happens the same way in Hong Kong and in Singapore as well. In abroad market, it also happens. And that's the reason in Hong Kong, the major problem is that whiskey prices or any kind of product prices varies a lot from shop to shop. And that is the reason they come up with this particular application where you can get, all the recommendation of the whiskeys you like as per your flavor. If you like smoky flavor, you will get a whiskey. If you want some other flavors, you will get a whiskey. They've also done some image classification and image identification. If you just show your image of the whiskey, be it any kind of image, they will be able to predict the image as well. uh, Basically, they will be able to predict the whiskey labels and all those things, and based on that they will also be recommending you a lot of things. So if you want to have a quick look on the live demo, this is how the live demo looks like. So they have a search by image where you can just quickly browse, quickly upload your image, and you will be able to see whether which type of whiskey this is. And okay, this is a Lagavulin 16, and search by flavor profile. So a lot of things are there. You can see the word cloud, which shows you which type of whiskey it is based on some external reviews. Price distribution across the market, different shops selling it at different cost. You can also navigate, check out their Google Maps location, and you can also check out their shops. recommendation systems showing you the, what are the likelihood, what are the nearest whiskeys to your brand, what are the recommendation, opposite recommendation to it. So a lot of things has been done. They have also done some flavor analysis. Based on your flavor, they will be recommending the customers as well. So a lot of things are there, guys, and we have them waiting in the waiting room. So let's get started. Let's meet them. Hi, Kelvin. Can we have a small introduction about you?
Oh yeah, sure. So I'm Kelvin, and I used to study data science and statistics in university. And right now, I actually try to go in that industry. So me and two of my teammates are joining together to work on a project, try to utilize our data science and statistics skills, and also in machine learning and deep learning aspect. So we have done the project. So we want to show you guys about what we have done.
Great. What about you, Brian? Can I have a small introduction about you?
Yeah, sure. Hi, I'm Brian, and I was a web developer previously. And after I dropped my jobs, I joined a course called the Data Science and Machine Learning, and I met Stephy and Kelvin there, and we have made our new project. It's called WhiskyNav, which is about the machine learning to learn to recognize the whiskey. And yeah, here we are.
Oh, amazing. Hey, Steffi, can we have an introduction about you as well?
So hi, I'm Stephy. I'm from the hotel industry actually. So after handling so many guest data, I start to wonder how like data can affect our like business decision and also different kind of business strategy. So I joined the data science bootcamp and then I meet my group mates. So after the bootcamp, we developed the app as our final project to help people to choose the correct whiskey for enjoyment.
Amazing. I hope you already had a fourth member as well who's missing out in this call. Her name is Sofia. Unfortunately, she couldn't make it up. Okay, let's move on to the next topic, which will be on the business understanding. Like, what exactly is the business problem, and what are you trying to solve in this one? Can somebody explain?
Yeah, I could explain it a little bit more. So, as Brian and Steffi mentioned, we all love whiskey. So, we always want to try to buy a new whiskey to try, but we always encounter the common problem, a common pain point. So that is, we don't know where to buy it and what whiskey to choose. So every time we try to buy a new whiskey, we have to do 2 hours of research trying to pick the best buy, the best whiskey here. So we kind of noticed there's a gap here. So those people who know whiskey well can of course know where to buy, right? But not for us. So we can see there's a gap here. So this is also a entry barrier for common consumer like us. So we were quite lost. We don't know where to start. So after maybe 2 hours of research, I kind of want to give up and don't want to try the whiskey anyway because it's hard work, right? So we noticed that if we can close this gap, we could actually bring in a lot more customers to the whiskey world. And the second problem is the term whiskey is a very generic term because there's so many varieties of whiskey here. So, for example, like me, I like smoky whiskey. So when I go to the online store, I will try to search smoky whiskey. They would give those websites would give me lots of recommendations, but those recommendations are actually not accurate. Like they would give me some fruity whiskey or some with another flavor here, not smoky at all. So I was wondering, what if we could use our data science and machine learning skills to try to build up more accurate recommendations so that those who know their flavor preference can pick the whiskey they want. So that's why we want to pick this topic here.
Amazing. Can you quickly talk about the tech stacks used, like NLP or deep learning, and what neural networks on a very brief basis, and then we can start with the project use case probably.
Okay, I can briefly introduce what our end product is. So it's very simple. You can take a picture of any bottle. So that apps would actually recognize what kind of whiskey it is. So after recognizing it, it would scrap real time all the online popular retailer platform and scrap all the reviews from the users. So after scrapping it, the apps would actually consolidate all the information and show you the flavor profile, the price, and where to buy the whiskey. So I don't have to do a 2 hours research anymore. Just take a photo, and the apps will actually tell everything about it. So it's very convenient.
So in another way to use the app is if you have special kind of like preference in terms of flavor, actually you can tell us your flavor of the whiskey, and then we can also do our flavor analysis of that whiskey. So we can also give you the word cloud about the to visualize taste, and also the price range, the shop list that you can get those kind of whiskey as well. And also we will also give more recommendation on similar type of whiskey or completely different types of whiskey.
Amazing, amazing. Sounds amazing, guys. Can we have a short code walkthrough or a product walkthrough kind of thing?
How about I show you the live demo of what the final product looks like. So let me share my screen here. Hold on a second. So you can all see this screen, right?
Yeah.
Okay, nice. So we have recorded a video. So right now you can see this is our app. So imagine you're taking a picture like the one here. So you've taken a picture, you don't know what it is, you want to know more about it after you tried it in your friend's house or in a party. So after you take a picture, upload it to our apps here, the apps will actually analyze the picture and try to recognize what brand and year of the whiskey is. So right now you can see, could correctly identify it as the 𝓐𝓰𝓮𝓷𝓭𝓪 16. So after clicking it, so right now the apps is trying to scrap all the information online in real time. So it will scrap all the retailers in Hong Kong and all the online platform. So now you can see, the first thing you can see is the word cloud of the flavor people say online. So without tasting whiskey, let me go back a bit. So without tasting the whiskey here, you can, judging from the word cloud, you can already tell the 𝓐𝓰𝓮𝓷𝓭𝓪 16 is a very smoky, peaty whiskey here. So below that word cloud, you can actually see the price distribution. So you can see from the graph, so most of the shops in Hong Kong is selling it at about $750. So if you're inside the shop and the shopkeeper is trying to selling you at $900, just run away. It's a scam, right? So you know the price distribution here. So below this price distribution here is a shop list of all the shops selling this whiskey. So you can see there's a shop name, the address, and what price they're selling. So instead of just reading the address here, you can actually click it. So they will lead you through the Google Map. So after clicking it, you can go to Google Map and you can go there directly. So you don't have to do more research about it. So below the shop list, you can see there's 2 lines of recommendation here. So the first line of recommendation is recommending whiskey, which has very similar flavor. So remember, 𝓐𝓰𝓮𝓷𝓭𝓪 16 is a very smoky and peaty whiskey here. So the first line of whiskey is very similar. Like the Outback 10 is also a very smoky whiskey here. But some user, some consumer may want to try something completely new. So we offer another line of recommendation, which is the opposite. I would say I would use the word different here. So this line of recommendation is actually recommending very different whiskey here. So like the Tom Martin 12, all three types of years here. So we can click one inside to check its flavor here. So like for the Tom Martin 14 here. So remember, this is a very different whiskey. So you can see the word cloud here. It got a strawberry taste, chocolate taste, fruity taste. So it's very different from smoky here. So that's how we do it. We can offer a very similar or very different one for different kinds of consumer. So that's one way to use our application here. So instead of uploading the image, you can actually specify what kind of flavor you want. So everyone know what kind of food or drinks they like, right? So we actually offer offer some adjectives here to describe the taste. So like, for example, do you like smoky, do you like winey, honey, or fruity here? So after sliding the bar here, you can already search the flavor here. So there's a reason, we can explain it later, why we picked these 4 adjectives to show first. So we will explain it later. But after clicking the 4 flavor, you can search it already. But of course, some dedicated users may be very specific about their preference of whiskey. So we offer 8 more. So in total, there are 12 adjectives describing the flavor of the whiskey. So you can still adjust the bar here, depending on your preference. So after that, you click it and then you click search based on it. So judging from this profile, you know, we are searching some very smoky whiskey, which have a very rich body here. So let's see what the search results will give us. Of course, smoky whiskies is Lagavulin 16 and Outback. So you can just click inside. We go back to the previous page where we will show you the word cloud, the price, the available shops. So yeah, so that's our apps here.
Good one. So what's next? So are we going to have a small code walkthrough as well of the product? Because the product looks amazing. Like it has a lot of features. I can understand that. So can we have a short code walkthrough as well?
Oh yeah, sure. So Steffi, you start first about the wrap scrapping. Are you muted by it, right, Steffi?
Sorry. I mean, is this set one the code for the actual program instead of the code that we collect our data?
Yeah.
So you want the actual program, right?
Yeah.
So I think, Kelvin, you need to talk about the image recognition model and also the flavor analysis part.
And the recommendation.
We could, but are we going to show the wrap scrapping?
I think wrap
also?
scrapping is not.
I think it also can show a little bit.
Yeah, we can show a little bit. Just a brief introduction, like this is what we do, how we scrap it. Yeah.
Yeah,
Okay.
maybe do the beautiful soup, etc.
Sure. So maybe I show my parts first. Instead of the code, maybe I will also show the end product, the data that we created, because we actually scrap all the our own data.
Yeah.
So just a second. Let me share my screen. So can everyone see my screen?
Yeah.
Okay. So as we all know, like the same kind of whiskey may name differently in different websites. So the first problem that we need to solve is how we can locate the same bottle of whiskey in different websites. So so from the first beginning, actually, we are collecting our data from the whisky.com, because the whisky.com, they have a rated list of different kind of whiskey. And then we can sort out all types of whiskey and select the top 100 whiskey that the most popular top 100 whiskey, which because there are so many whiskey in the world and it's very hard to get all the whiskey for the image recognition. So we create a list first, and here is the code that I website for the whisky.com. And they only collect the distillery name and also the year of that whiskey. That would be the key for us to locate certain kind of whiskey in that in a particular website. And so that would be the code. Yeah. And I can show you the end product. Can everyone see the CSV, the Excel file? Is it shared?
Not yet.
Okay. So now should be shared.
Yes.
So this one would be the final product for the first part of the web scraping. Here is the list. First column is the distillery name, and then the second column would be the year of that whiskey. And these two will be used together as the key to locate that whiskey in the website. And after that, we have the top 100 whiskey. We collect the link of the whiskey from different websites.
And these list of whiskeys are sorted as per their rank, right?
Yes, it's sorted by their the rating on the whisky.com. So we can either use the index or the distillery name plus the year to locate that whiskey.
Yeah.
Okay. And then, so here comes the second part. So the second part of the code is we actually not web scraping the particular whiskey information directly from the website. Instead, we collect only the whiskey link for the link that the user can actually buy that whiskey on that website. Because the reason why we do that is because we want to have a data frame that can be updated currently. Update like regularly. So we just collect the link of that whiskey, and then whenever we need to update our data frame, we just go inside that website again and to do the web scraping again. So that would be the code, and then we do web scraping on 3 websites. One is the Hong Kong liquor store, and also the Watson's Wine, because this two is the most popular online liquor store, and they have both online and offline stores. And also we do web scrape for the price.com, because the price.com is a very popular platform in Hong Kong that they have list out all the small shops in Hong Kong. So the user can either find the big chain liquor store or the small shops, small local shop to find a particular whiskey. So the end product will be like such. So this one would be the end product. So we have still the same list, the distillery name and also the year of the particular whiskey. And then is the link from each of the website. So whenever we need the data for the particular whiskey, we go inside the website and do the web scraping. So the third part is to get the whiskey price and also the, just a second, the whiskey price and also is it available inside the stock.
Yeah.
So I will show the code first. So I take a Hong Kong liquor store as one example. So for the web scraping part, they will take whether is it in stock. If it's in stock, then we will get the data for the price. Mainly for Hong Kong liquor store is for the price only. So for each of the website, we will create a list like this. Like this one. This one is the Hong Kong liquor store. Also, we have the distillery name and also the year as the key. And then here's the link and also the price. So we also have the stock information, whether it's in stock or not. So whenever we need to get the data, we will review the data frame and just get the particular whiskey, the price, and is it in stock. If it's in stock, then we'll be shown in our apps. If not, then we'll just show other websites information. So that's the all the parts for the whiskey data.
Yeah, nicely done. Yeah.
So is it Kelvin? You're talking about the image, or I need to talk about the image as well?
Kelvin, you're
muted. You muted.
Oh, I can talk about the deep learning part.
Okay. So for the image also, right?
Yeah.
Okay.
So share screen. So right now I'm going to share how we do the image recognition, how to train a how to use deep learning to create a model, so that whenever we upload a image, you can recognize what kind of whiskey it is. So before we do that, I'm going to show you the structure of our program. So we have 3 programs to do this job. The first one is what we call the image multiplier. What it is a image augmentation script. I will show you immediately. So it augment the image for the neural network to learn. So the second part is the trainer. So basically it is what we use to train the model. I'll show you also. And the third one would be the tester. So after we train the model, we actually have to deploy the model to test it. So there's 3 parts here. So you can see there's a folder here called the checkpoint. So right now it's empty. So I'm going to train the model from scratch just to show you guys how we the whole process of training the neural network. So right now this checkpoint is for saving the weight of the model. It's going to have some file later on after press the training button here. So right now it's empty because we're going to do it from scratch. So there's nothing here. Another one is the image folder here. So right now I have say, I want to train a model to recognize 3 kinds of whiskey. Like the first one we call the Outback 10. So inside the Outback 10, we've got how many photos here? 20 photos of Outback 10. So all with a little bit of variation, all focus on the bottle. You can see the background is actually a little bit different here. 20 photos here. The second one is the Brunatic, very iconic whiskey here. And the third one is the Lagavulin 16. So for our product, we actually train more than 100 whiskey. But for demonstration, we're going to do the simple way. We train 3 whiskey here. So that's the whiskey training image here. Another folder is the testing one here. So this one is a completely new image. We're going to use these photos to test our final model here to see if we can recognize the correct whiskey here. So you can see there's a brand new photo here. So later on, we will use it to test. So the first thing we do is we want to actually augment the photo. So why do we do it? Because say, for the Outback 10, we got 20 photos here. That's not going to be enough because we, for our first approach, we actually just train it as is. So we use 20 photos to train the model, and we found that the accuracy of the model is actually bad, not good at all. So after that, we think about how to do a new approach, and then we think, why not just multiply, upsampling the images we have. So we use image augmentation to multiply, to augment the image a bit and multiply the sample size. So we do it right now. Let me show you the code here. The multiplier. So say, so this is the code for the multiplier. So first step here, I actually manipulate, we do not want to load the image because we have so many photos here and we might have memory problem if we try to load all the image at once. So instead of loading and reading the image, we just actually manipulating the file path of the image. So once it is ready, we will load the image on demand. So that's how we do it. So right now we define the file path here because all the photos is storing inside the image, right? So we just set up the file path here. And then after setting it up, we're actually trying to read the image here. So that's what this part is. So the first thing we do is that we create a loop. It will loop through the whole folder image here. It will loop through it, but it's going to check if it is a file, if it is a valid file, and also if it is a correct file type. So you can see we can read PNG file and JPEG file, and also in capital letter because some of the image we download, they use capital letter, so we type it in. So if it fits these 2 conditions, it will actually open the image according to the file path. And also we check if it is in RGB, red, green, blue mode. We check if it is. If it is not, we'll convert it. So if it is in RGB mode, we will actually try to resize the image here. So all the image we have here is actually have a very high resolution, but also the memory problem here. So we try to reduce the size. We try to limit it to 250 to 250. And also we apply a little bit of what we call the image improvement process. So if you're into gaming, you may know this technique. So let's say if we have a very high resolution or low or any photos here, if we zoom in too much, the smooth curve is actually look like a very rough, very they got a very square edges here. So we want to smooth that out. So we use this part to do this. So after we resize it and do a little bit of image improving process, we save the file path here. And also we specify the format as JPEG here. So whenever what type of file we read here, after we resizing it, we will save the data in JPEG file. So here, this is the quality part. So normally we will set the quality at about 75 to 9, between 75 and 95. So the higher the quality, the bigger the size. So I picked 90 here because actually we limit the size here so we can afford to be having a little bit higher quality here. So after that, we would actually build a sequence of actions to do the augmentation. So here you can see I have a sequence here. This is the whole list of the augmentation. So you can see at first, the first augmentation I'm going to do is to trying to flip it, to actually flip the photo left and right. But later on, I disable it because I realize that when you take a picture of the bottle, you won't take it to the mirror, right? So that's in no case the user will going to flip the image. So I disable this part. Another augmentation is the crop. I will cut the photo a bit. And also I will add what we call the Gaussian blur. So we will try to blur the image a bit. So right now the stock photo is very clear, but sometimes the user may take a photo which is not in focus. So we try to blur it a bit. And also we will try to adjust the contrast here. And also we will add the Gaussian noise. So this effect would add some random noise to the photo just to mimic a real life photo here. And also we will multiply the value by a factor, by a range of factor here. So multiply the value will actually adjust the lightness, the brightness of the photo. And also we will use these four effects just to transform the image a bit. In what way? So the first one is scale, actually zooming in or zooming out of the photo. This is scale. Another is we try to translate percent. It's a very complicated name, but what it does is actually shift the image left and right, up and down a bit. And also we have a little bit of rotation here. We specify the angle here. And the last effect we were trying to do is the shear. So it would try to shift the, how to describe, like we have a photo here, like these four, right? This is a standard photo. What shear does is actually shifting the photo like this. This is what we call shear here. So it would do this kind of effect randomly. So you can see I specify the parameter by the range here. So each time the program will actually pick a random value between these parameters. So each time the program would look into the image and they will pick a random number of effects and apply it under random magnitude here. So this is the augmentation effect we're going to apply. So here we will specify how many times we're going to apply the augmentation. So say we have 20 photos. If we augment it 10 times, we will actually generating 200 photos here. So I just pick a number I feel comfortable with. So let's say we put 8 here. So it would this time we go into a for loop here. It would do the whole sequence 8 times in generating the image. So let's do it right now. So after loading the model, I specify so after running it, you can see the program will actually do it one by first from the Artback 10 and then the Lagavulin 16. So there will be some warning if the image is in this format, but this is still okay. Still okay. So let's check the result. So you can see in the original photo, we have 3 whiskey here. So after clicking it, you can see all the images have been augmented by the program already. So right now we have 180 items because we've augmented 8 times plus the original 20. So we have 180 photos here, all augmented. Same for the Bernardek here and the Lagavulin 16 here. So right now we got all the images done. The next part is actually training the model. So that will be the training part here. So same rationale. First, we want to use the file path. We don't want to load the image data all at once. We want to manipulating the file path here. So this is what we do here. And also we try to label the whiskey one by one. So these 3 lines of code is actually naming the whiskey, because when we are training the neural network, we can't actually use the name. We have to give a label like the one-hot encoding, but we are training on 100 whiskey, so using one-hot encoding like 001 there is not actually not okay, because that would create a very large database here. So instead of one-hot encoding, we actually give a number to all 100 whiskey we're going to train. So this is what this line does. And also, once we have the label done, I have this code just to write the labeling result in a JSON file and save it inside this checkpoint folder. So why we do it is because when we finish training the model here, when we want to apply the model, we actually have to read the label. So we have to output the result. So this is what this code is doing here. So right now, after we manipulating the file path, we have to do the train test splitting. So we are using 80% and 20% ratio for the splitting. So for the training set, we use 80% here. So it will randomly shuffle the images the program read, and then take the 80% one. And the remaining 20% one, we go to the testing speed. This is the validation data set here. So after we set up the train test split here, we will actually build a model here. So this is what we do for the model. First, we actually pick a number of, we do some research. So we want to use a pre-trained model for the for feature extraction, and then we build our own model for training the whiskey. So the model we choose is called the inception review. So let me show you another graph here. Let me search here. So that should be clearer. Yeah. So these are all the available model, image recognition model online we could find. So you can see that a bunch of model which has very similar accuracy level here. So all are performing similarly. And also on the right here, this is the weight, the size of the model. So you can see Inception got a bit smaller size compared to VGG here. And VGG actually, no matter 16 or 19, got lower accuracy. So we just randomly pick one for our model because they are performing equally well, right? All above 75% accuracy. So at the end, we pick Inception Briefly because it has relatively small file size here. So that's why we pick it. So after picking Inception Briefly, we know that Inception Briefly is an image recognition program for recognizing dogs and cats, all kinds of general objects, but none of the objects is actually whiskey. So we use that for feature extraction only. So that's why we actually, for this part, including top, we input it as false. So what we do, let me show you another photos here. So this is the model for the Inception V3 here. So the body part is for the feature extraction, but for the final part is for the classification part. We cut that out because we want to do our own whiskey classification. So specifying false for this parameter essentially means that we cut this part out, and then we build our own neural network on top of it. So that's what we do here. So after cutting the head out, we freeze the rates of the inception VV here. So that's how we freeze it. Then we build our own model. So there's a sequential of steps we do here. First, of course, is the inception VV here. And then we try many versions here. This is the final version we use. So first we will try to use the global average pooling just to get the average of the output of the inception VV here. Then we flatten the result, and then we pass it to 2 hidden layers here, each with 202 hidden looks here. Because we are training, we're actually training 101 classes here. We want to double the amount, so that's why we use 202 here. But for this case, we're training 3 whiskies, so that will be an overkill, but it's still okay. We're going to do this way. So the last layer is for the classification part. So this here, we specify it as the length of the label. So if we got three folders, if we got 3 folders here, this part will be 3. So if we got 100, this part will be 100. So, and of course, we are actually classifying over 100 whiskies. So the activation model, we actually use softwares. So usually we use another activation called sigmoid, but for that, it is for the binary classification, not for the 100 whiskey. So for 100 whiskey, this one would be much better. I can explain a little bit more about the math behind here later. So that's the model here. So after constructing the model, we can compile it. So this is the optimizer we use. Again, we have done a little bit of research why we picked this here. There are many optimizers like the Atom or what we call the Atom Max, lots of different optimizers. But at the end, we choose this one, the root mean square propagation. So what this does is actually taking the square of the gradient descent. During the gradient descent, there's a partial derivative. So how much the rating is going to change there. So it will take a square there and will take a root mean square of that. So essentially it means that this model will actually checking a moving average of the adjustment of the rating, of the square of the rate of the change of the rating, taking the moving average, and then they will adjust the learning rate according to the moving average here. So essentially it means that whenever the learning rate is going slow, this optimizer will actually speed that up a bit. But if it is going too fast, this optimizer will slow down a bit. So this is what we pick. So there's a research, lots of research on comparing different the performance of different optimizers. So we found that this one is actually better in image recognition task. So we picked that. And of course, for the loss function, we're having 100 class of whiskey here. So we are using sparse categorical coarse entropy here. And then specifying matrices as accuracy. So this one here, we didn't use it in this case, but when we're doing our training, I specify every 20 epoch, I'll save the weight. So whenever there's I want to extract a rating for the mid epoch, I can do that from this part of code, but right now we're not going to do it. So after constructing the model here, we can actually do the training here. So let us run the program right now. So now, okay, training the model. So right now you can already see the model is starting to train now. Because we're training 3 whiskey, right? So the training time, we don't have that many images. So the training time is actually will be quite fast here. So you can see for the first epoch, the accuracy level is already here. And the validation accuracy is actually here. So you can see it's actually looking good. And you can see for each epoch, the accuracy would increase bit by bit. So you can see this model is actually learning good here. So we can wait a bit. We specify 10 epoch, right? So midway through is already reaching 92% of accuracy. And the validation accuracy is actually quite good here. So at first I really would it be overfitting a bit, but right now, these two values are very close, so it's looking good right now. So give it a little bit more second here. Wow, 99%. Don't know if it's true or not. Okay, so the model is done. So this part, let me show back the code here. Okay, code here. So right now, after training it, it will save the rating in the folder here. So right now, if you go back here, you can actually see there's a bit of file here we just created. So the rating is actually the rate of the model, and the label to test is the label we created for this training set here. So we got the rating already. So we can plot the graph to see the accuracy. So these whole bunch of lines of curves are actually plotting the accuracy plot here. So you can see the accuracy actually keep improving, but you can see it fluctuates a lot. So there are many possibilities of why this is happening, but the most probable reason is that the learning rate is actually too high. So it's actually bounce during the gradient descent. It's actually bouncing around, not converging on the minimum value. So we can actually limit the learning rate here. So that's what we do for our model. So we can actually, from this line of code, we will actually load the model, load the rating here, and we can retrain the model, compile it again. This time we can specify the learning rate for a very small value, like I don't know how many, 60 here. So we can specify very limited learning rate just to convert it to the minimum for the loss function. So we can do it here. We can compile it here. So it will continue the previous training. So right now I actually set the wrong value here because the initial epoch I set it to 15, should be 10 here because we train 10 here, but it's still okay. We just train 3 more epochs here. So it picks up the previous rating, and then this time it is training using a very small learning rate here. So you can see the accuracy actually converged to very close to 1 here. So we plot the graph again here. So you can see after we specify to a very low learning rate here, both the validation and training accuracy actually skyrocketed and making it close to 1 here. So that's how we train the model. So right now the model has been trained for the free whiskey here. We can actually test it. So to test it, we can use this part, the testing part here. So still the same, we actually load the model here. We load the model here. And then it would actually read the file here in the testing folder. So in testing folder here, we got three images here. So we want to test it. We load it here, and then we will actually call the model here and use it to predict which class it is. So right now we actually extracting the index of the maximum value. So because for the prediction of the model, it would actually output the probability of that whiskey belonging to a particular class. So we have 3 whiskey, we actually output 3 probability. We don't want the rest, we only want the most probable one. So that's how we want to extract the maximum value here. So after extracting the maximum value, it would actually, this line of code is actually not necessary. So we actually refer back to the label names we created previously. That is this text here. So right now we have 3 whiskey here. So this is the JSON file. Pattnaik is 0, Pattnaik is 1, Nagabudin is 2. So you refer to this this string here to output the correct name of the whiskey. So let's do it right now. So we load the model, run it. Okay, finish loading. Okay, right now we can actually classify the whiskey. So we have 3 photos here. The first one is Pattnaik 10. So let's check the result. Give it some time. So you can see this is an image it hasn't seen before. This photo is taken in my home. So up at 10, you can actually up at 10 here, up at 10 here. So for this photo, you can recognize within 16. And for the Pattnaik, you can see the model got it all correct. So the previous accuracy model we see here is actually looks like it's correct. So that's how we train the model. So right now we are trying to train 3 whiskey here, but let me show the actual whiskey we have. So let me see here. Oh. So for the actual models here, we have this list of whiskey. You can see instead of 3, we have actually a lot of whiskey here. There's a 101 type here. So why 101? The top 100 whiskey, and we have a class called not whiskey here. So this is the image we train the model, try to recognize something not whiskey. So for example, if we want to test another here, like I have a bunch of non-whiskey photo here, you can actually run this program to test it. Oh, sorry. So for our model, I forgot to mention. So previously we trained 3 whiskey. It took about a few minutes. But if you want to train 100 whiskey here, so that training will actually take more than 13 hours for the model we try. But before that, we actually try countless models. So it took over a week to train the model. So this is the final model we train. So you can see, you can recognize a lot of different whiskey here. So say for the 𝓐𝓰 12, you can recognize 𝓐𝓰 12 here. Highland Park 12, no problem. Talisker 10, no problem. You can see it got all correct. Even Highland Park 18. Highland Park 18 and 12 is very similar, right? So you can still recognize it. Of course, this cartoon here, not whiskey. The flight 10, no problem. You can see got it all correct. So for this one, not whiskey. So this is our final model here for the rating. And if you check about the rating here, it is about 87 map here. So this is all good, not too large. And the accuracy is actually very good here. So yeah, this is how we train the image recognition model here.
Good job, good job. It was really nice. Yeah. Do we have the next part, or that's it? Like, we do have the anything else to talk about?
I can talk about the recommendation and how we build the word clouds. So let me share my
analysis.
Yeah. Just wait a minute. So, can you see my screen?
Yeah.
Yes. Okay, so let me talk about the recommendation first. So actually, our recommendation system is based on a database which is built by the international whiskey communities you share. So they gathered the vast of whiskey from all the world to rate the distillery of whiskey usually in European, etc. I think, and they have 12 kinds of standards, including the body, sweetness, smoky, etc. And they rate from 0 to 5. So each distillery actually have a rate of 0 to 5 for the 12 relatively independent flavor profile. So, and based on this database, we want to calculate how similar of our searching. For example, we search for a whiskey with a distillery called 𝓐𝓰𝓮𝓷𝓭𝓪, and then we calculate their cosine similarity. So why we use cosine similarity but not Euclidean distance? And because we believe that compared with the absolute values for the independent flavors, the balance between them is actually more important. So as a result, cosine similarity suits this situation. So this is what we use. And here you can see that we can add the whiskey name that here, and then you compare with the other distillery using the cosine distance, and then they will pop the top five similarity, and then using these similarity factors that we can do the recommendation that match back to the top 100 whiskey database that Steffi have just searched for. Then we want to filter out the whiskey that belongs to those top 5 distillery.
Yeah.
And on the other hand, we also in our apps we have also searched for the whiskey using the customize the flavor profile, which is also here. We can make our own flavor profile, and then we'll also run the calculation to compare with all these distilleries, so that we can do the same thing like we have just done before. Like we just input just like what I just said before, to input a whiskey, and then they recommend this whiskey belongs to the top 5 distillery with high similarity. And here is the recommendation part. As for the word cloud, I actually do some web scraping from a website called Master of Modes. So based on the database of the top 100 database of whiskey, we search for their whiskey IDs, and then we do web scraping to search for what? To search for the reviews of them. Each whiskey will have their own independent reviews, and then we combine these reviews all together into one document. So one document per whiskey. And then we run the TF-IDF vectorizer to organize them. And TD-IDF is usually the full name is turn frequency inverse document frequency, which is search for the words that are common in a particular document, but not quite common in the other documents. And then here we run when we collect our reviews and runs the vectorize to use the TD-IDF vectorizer to learn them. And then in the website that we see that we have a great kind of the word clouds which actually run in here, we actually get the ID of that whiskey, and then we search for the reviews that belongs to that whiskey, and then do the vectorization and print out the word clouds, and then we transform that word cloud into PNG and send back to our apps. And finally, here we can see that we have integrated all our parts, like Kelvin's part, Steffi parts, my part together into our Flask server. So let me see how it works. So here, in the front end, you can see that we have the searching image part, the searching flavor parts, and we have the detailed page for each whiskey. It's actually all the data all come from here. For example, the search image, actually we upload the image from the front ends and then undergo the searching process through the classifying method that provided by Kelvin, and then it will in turn to returns back to an index that is came from Steffi, and then we collecting data, the information, the shopping information, or etc. to combine all of them into a JSON file, and then return back to front end. It's actually a similar case for the searching flavors, which we use the customized flavor profile, or the title page also is doing the similar things. Actually, all the things, all the information we get is packed into the JSON and returned back to the front end, which we built in React. Yeah, that's all.
Amazing, guys. Very good project. I really liked it, as I already told you that this is one of the it's a very fascinating project and very nice project. So I hope everybody likes it, and we will also be sharing the code in case anybody needs it and anybody wants to practice it. Of course, they can try it out. And I have already shared the LinkedIn profiles of Kelvin, Steffi, Brian, and Sophia as well in the description below. I think yeah, that's it for this video.